Reminder, these are the steps we're using to solve any type of logarithmic or exponential equation. This video will be on what if you have exponential equations on both sides of the equal sign. So what if you have something like this? Your textbook and many other people suggest for specifically a problem like this, where you can write 9 as 3 squared, to change this into 9 is 3 squared. You would multiply that 2 by whatever else was in the exponent here, and now these bases are the same, so you can set their exponents equal to each other and solve for x that way. Yes, this way is super quick. I am going to show you the other way though, because as you can see here, we're not always going to be able to rewrite 5 in terms of 4 or 9 in terms of 3. So this is only a special case, and so if you want to learn that way, if that makes sense to you, go for it. But a lot of people don't know their squares, their cubes, their fourth powers, so it's not as quick for them to pick something out. And so I'm showing you that method for you to be aware that it exists, but we are going to solve using the same 5 steps we used before. Nothing has to change if you don't want it to. Okay, but we can skip step 1, isolate, because we have 2 things here to isolate, so instead we're not going to really isolate anything. Let's go on to step 2, convert to a logarithm. All right, we need to put logs in front of both sides here. They have to have the same base, so they both have to be base 3s or they both have to be base 9s. You can choose which one you want to do. I usually just go with whatever comes first, so I would put base 3s on both of these. It's probably smarter to just pick the base that has the more complicated exponent. The reason we put the log base 3 is over here on the left. The log base 3 and the base 3 cancel, and we just have an x plus 1. And over here on the right, nothing cancels, but we can move our exponent out front, if you remember that property of logarithms. So I'll have x times log base 3 of 9. And why would we do that? It's because step 3, this is all calculator buttons we can type into our calculator. Use change of base if you need to. That should be a 3. When I type this into my calculator, I get a 2. Make sure that you multiply this 2 by everything that was in the original exponent. In this case, it's just an x, so it's not that big of a deal. So 2 times x is just 2x. All right, now we're on step 4, solve. So I need to move all of my x's to one side of the equal sign. Oh, 2x minus 1x is just x, and we're there. You can double check your work. If you plug a 1 back into this side, you'll get 3 squared, which is 9, and if you plug a 1 into this side, 9 to the 1 power is 9, so the left side equals the right. Perfect. Let's do another example where the bases can't be rewritten, so you have to do it this way. All right, so we don't need to isolate again because we have multiple exponents, so can't isolate because how do you choose which one to isolate? So let's convert. We want to put logs in front of both sides. They have to both be base 5 or both be base 4. You can choose. I generally pick whatever this first base is. No other reason than that. That means on the left-hand side, the log base 5 and the base 5s cancel, and this x plus 2 is just a normal equation. And on the right-hand side, my exponent comes out front. Write it in parentheses so you realize that the whole log base 5 of 4, this whole number is multiplied by each piece of the exponent. All right, step 3, type this into your calculator. So log of 4 divided by log of 5, I used change of base formula right there. technically you should wait to do this step last so you have an exact answer or a more exact answer. So when you do Alex, you may want to move and wait till the very end to type into your calculator. I think that this is a little overwhelming of all the steps you have to do, and so most people do better with decimals throughout. So on your test, you can use decimals throughout. I won't count off for rounding. All right, this 0.86 needs to be distributed to both pieces of my original exponent. And now solve for x. That means get all of your x's to one side of the equal sign. It doesn't matter which way you do it. I don't like negative, so I'm going to move that one over. And now solve for x. Subtract your 2. And divide by 1.86. I get that my final answer is negative 0.61. You can double check by plugging that back in to your x's, and if you plug it in, this number is the same answer as this number. All right, let's do 2 more examples. This example C is the same as an example in your notes. However, I've switched it around and put the 5 first because I wanted you to see I used base 2 in the notes online, but I'm going to use base 5 on this example, and you should get the same answer both ways. All right, I don't need to isolate, but I do need to convert. So I'm going to put log base 5s in front of both sides. You could also put base 2s in front of both sides, log base 2s. That will cancel everything over here on the right. And on the left, I need to move my exponent out front. And use change of base to calculate this number here. Solve for x. That means I need to distribute move all of my x's to one side of the equal sign. And divide. You can double check your answer, plug that 0.27 back into both exponents. Last example, here's another one that you can rewrite 16 as 2 to the 4th power. You just need to be aware of your powers. I'm going to use the same steps we've been doing. So I'm going to convert. I'm going to put log base 2s in front of both sides. That means on the left side they'll cancel, and on the right side you bring your exponent to the front. Use change of base. And now solve for x. So distribute move all of your x's to one side of the equal sign. And divide your negative over. You can check your answer. If you plug in a -4 here, you'll have 2 to the -12 power. If you plug in a -4 here, you'll have 16 to the -3rd power. When you type that into your calculator, they should equal the same decimal. 2, -12, 16, -3.